All right, yeah, hi everyone. My name is David, and I will be talking about Forest, which is a Filecoin node written in Rust. I work for ChainSafe, which has for the past 3 or 4, maybe 4 years, been funded by Protocol Labs to develop an alternative client, alternative Filecoin client, and also help out with like different architecture things. And like most recently, we were quite involved. We were quite involved with the FVM, and many of the built-in actors were written by people on the Forest team. So what we want to do, ideally, was to look at the Filecoin spec and then create a client that fulfills this spec. Unfortunately, the spec is somewhat incomplete, and it often just refers to Lotus. Lotus is the gold standard, and we are always just trying to like mimic Lotus as much as possible. So this means if Lotus does something we don't understand, then we just like keep our head down and then like try to do the same thing. And the spec is quite complicated. I don't know if you have all read the spec. There will be a session later where we'll go through some of the inaccuracies and like try to fix them in the spec. But it's quite complicated, and there are a lot of moving parts. And it's not just one thing. It's like an involving document, because we have, what is it now? We are network version 20, so we have 20 different consensus rules. And we would like to make sure that like all of them work as expected. For each of the last 3 million epochs, we want to be sure that Forest behaves just like Lotus. And just looking at our code and their code isn't quite sufficient. So what we really want to do is like look at the source of truth, like look at the actual blockchain. It should be possible to take the entire blockchain, start at Genesis, and then like run through it with Forest and with Lotus and see if we generate the same result. Like it should be really easy, and it should be very doable. But we started looking around, like who has this data, like where can we get the blockchain? And it was quite difficult to actually find someone like who has the data prepared already. So we thought, okay, if no one has this data like pre-packaged, that would be really convenient. But like we don't really need it to be pre-packaged. The data is like regeneratable. So each block in the Filecoin blockchain has like two things that are like quite important. One is the state of each actor, which keeps track of like which miners are sealing which sectors, which account has such and such Filecoin. And then the other thing that each block contains is the messages, which are the transactions. So when you send some fill from one account to another, there will be a block that says, hey, like take the fill from this account and then move it to this other account. And then there will be a new actor state that has the updated fill amount. So we thought, okay, if nobody has like the entire data, then we can just take the messages, we can rerun them, and that will give us the entire state. It might take quite a while to like re-execute every single transaction, like from Genesis, but hey, why not? So yeah, we were fine with not having the actor state, but we absolutely need the messages. Without the messages, the blockchain cannot be generated. So we went out on like the peer-to-peer network with all the nodes, and we started asking them both for the actor states, if they had them, that would be nice, and then we started asking them for the messages. And the nodes that are publicly available have the messages for the last 2 or 3 months. Beyond that, the messages were just gone. And we kept looking and looking because like this is like fairly important information, but no one had them. Like no one on the lib peer-to-peer network. Fortunately, like this information is not gone. It hasn't been lost. Protocol Lab with their Sentinel team have collected all of this data from day one, and they are making it available through a Google Cloud account. But when you want to have this data, you have to pay the egress fees, and that is quite expensive. So this is not as easy to get this data as I would have wanted. And it's not even that the protocol labs are taking a cut. Like they're trying to provide this data to as wide as an audience as possible, but like just paying the egress fees for 40 terabytes of data means that we would have to pay $4,000. And ideally, like we would like take the chain and then like do some computations and like do some checks and then like throw everything away again, and then like a month later do the same thing. But if we had to pay $4,000 every time we wanted to access this data, then that would be too expensive for us. And like, so why is the data so big? That's one of the things that we started looking at. We at Forest have spent a lot of time trying to make it faster to generate these daily snapshots. So if we could make these snapshots smaller, then it might be possible to save some money on storing like the entire archive. And as this graph shows, the size of the snapshots has grown significantly. And after network 16, there was a slight mishap that caused the size of the data to just explode, which was then fixed in network 19. And if you want the entire state, then you have to get every single daily snapshot, and this means that you need to download more than 40 terabytes of data. Fortunately, the snapshots are not a very efficient way of storing the blockchain. Most of the data in a daily snapshot is the same as what was already included in the previous day's snapshot. So we started generating and storing only the data that has changed. And this completely changes the the size profile and the growth of these snapshot files. Instead of each day the snapshot files being bigger, the amount of new data is actually the same now as it was 2 years ago. I'm not quite sure what that means, because I would assume there would be more users and more miners now than there were 2 years ago. But the amount of new data in the graph is the same. So storing this data when it doesn't grow is a lot easier. To store the original snapshots, you need an exponential, or the growth curve becomes exponential, and you need to store a lot of data and pay a lot of egress fees. But only storing the difference means that you can like really cut down on storage. So this is one of the things that we've done. We have taken this data and made it available. It is only half the size of the Sentinel data, and we don't have any egress fees. So all of this data is available through Cloudflare R2, and anyone can use it. So we are using ourselves just for testing, and like we'll continue using it for testing. But I'm sure other people will have like other things that they want to do if they want to set up a full archive node, or if they want to store the data in Filecoin, which I think it really should go in Filecoin somewhere. So okay, going from 40 terabytes down to 20 is nice and all, but 20 terabytes of data is still quite like a struggle to manage. At least like your scale is probably it seems like nothing. So loading even just 20 terabytes into Badger, which is the database that is used by Lotus, or RocksDB, which we used to in the past with Forest, or ParaDB, that has been especially designed to handle these workloads, is quite difficult, and it blows up the size of the data. As Arnie said, it is nearly 40 terabytes once it's loaded into the database. But the actual data can easily fit in 20 terabytes. So we wanted to access this data. If someone wants to look up, okay, how much fill did this account have 3 years ago, why do we have to load it into a database to just answer such a simple query? All of this data is available in car files, and we are all using car version 1, which is a very, very plain format. It's a list of key value pairs. And because it's so simple, it's very versatile. It has quite good support, but it's so simple that you can't easily index it. So people are working on car version 2, which, as you said, has an index at the end. But the tooling there is not quite mature. And for our need, we came out with our own version of car, which is backwards compatible with car version 1. And this is something that we did just to be able to make queries on this data without having to load it into a database. But this is not exactly a format that we want other people to use. We would very much want to collaborate on a better version of car version 2, because if the community could decide on a better way of storing this data, then that would save us a lot of trouble, and it would save everyone who wants Lotus a lot of trouble and a lot of memory.
If there's anything I can do to help with that, let me know. Banyan also got got stuck into the same problem, and they had to create a colorful interpretation of Car V2 to make it basically work for their use case. And to Banyan's credit, they are one of the only data onboarding functions that is not throwing away the metadata, but they're referencing it into a separate WNFS database, and the Car V2 indices are aspects of that, or they point to aspects of that database. But if there's anything I can do to help with a repackaging of Car V2 to make that stuff machine indexable, I spent about 20 years working on that kind of stuff for the storage industry, so we're going to connect.
That sounds great. Yeah, so as I said before, Car version 1, very widespread support. Car version 2 has no support and is quite awkward to use, but the intention is clearly that this is what you should use to properly store this data. And we very much want to take our variant of Car version 2 and then merge it into something that is usable for the wider community. That requires figuring out what people actually want and how we can all agree on a single format. Yeah, so loading 20 terabytes into a database, that is just rough. That is, it requires an extreme amount of memory, and being able to directly run queries on Car version 2 files would save us a lot of money and a lot of headache. Yeah, so that is a few of the things that we've been doing with Forest, and we hope to continue being able to make data like this available and make tools for manipulating such data available.
I'm going to repeat, when the EVM methods are going to be available?
So, well, as soon as we start actually prioritizing them. So right now we've just been putting them aside, but if we can work together, and then like have proper ETH support in Forest, and that would be great.
Sounds good to me. Yeah, we definitely need to have some chats because we would love to use Forest more. But for now, I mean, like we are the RPC provider, so how we can use the without the RPC methods?
Yeah, so far we've only been focusing on validation, but like we definitely want to have
You
a
did a
proper
great
RPC.
job. That's awesome.
All right, yeah. Then I will end my talk, and we can have a Sonny's talk.